So today we are going to subculture some cells that are on a 60mm plate. First thing we need to do is wipe down our bench with 70% ethanol. So just squirt your bench, grab a couple of pin wipes, and clean off your bench top. You're also going to need your P1000, a Sharpie, your dump bucket, tips, and solutions, timer, and hemocetometer and cover slip. So now we're ready to go. I've taken the plate of cells out of the incubator. You'll want to hold the dish like this. Take a look at them underneath the microscope to see what confluency they are. Examine the color of the media. It should be cherry red, and that you shouldn't see any cloudiness to it if your cells are healthy and cell culture is going well. You want to take your Sharpie and anywhere on the plate just make a mark. That's where you're going to be pipetting on and off the solutions. The force of the liquid coming on and off the plate will ruin the cell layer, so you need to only ruin one area of the cell layer. First thing we're going to do is aspirate or pipette off the media that's on there. My P1000 is set to 1000 microliters, and you just suck up right where that dot is. And there's 5 mils of media on here, so you're going to go back and forth 5 times. The cells are adherent. They're attached to the bottom of the plate, so they're not going to be sucked off while you're doing this procedure. So now we're going to add calcium magnesium free phosphate buffered saline, and this is going to wash the cell monolayer. We need to get rid of some of the components of the media that will inhibit our next enzymatic reaction. So we add 2 mils, pipette right onto that Sharpie area. And then you're just going to tilt to wash that plate. And you want to do this for about 15 seconds. Your cells are not going to come unattached at this point. Then take your pipette man and get rid of all that PBS. Now, change your pipette man to 500 microliters, and we're going to add trypsin. Trypsin is going to allow the cells to come off the plastic. Add half a mil right at that dot again. And now you want to tilt. Half a mil is just going to cover your cell layer. So tilt to make sure it's all covered. And then you're going to let it sit at your bench for 3 minutes. And now the cells are rounding up and detaching from the plastic. So your 3 minutes is almost up. Now what we need to do is neutralize the action of that trypsin, and what we use is media that contains FBS. There are components in the sera, in the FBS, that will neutralize the action of the trypsin and prevent it from further damaging your cells. Now you have to put on an equal amount of trypsin, equal amount or more of the media with the trypsin. So I just put on half a mil, and now the cells have become detached. I can actually see them floating in this media. To help any cells that are still attached to the plastic come off, I do a method called tap and tilt. So you give it a little tap. You don't want to create bubbles, you don't want to splash, you just want to add a little mechanical stress to the cells so that they come off the bottom of the plastic. Now you would go and examine this underneath the microscope to make sure that the cells are off the bottom. Set your pipette min to 1 ml, and now we want to transfer the cell suspension into a 15 ml tube. But what I'm going to do first is a method called titration, where you pipette up and down to break up any cell clumps. Now, a lot of students will create a lot of bubbles during this. A few bubbles is okay, but you don't want to create a lot of bubbles. So pipette up everything and transfer it to your 15 ml tube. Now if I was to take this plate and look at it underneath the microscope, I would see that there's still a lot of cells left. So we want to wash our plate with another ½ ml of the DMEM FBS to get up all those last cells. Put on another ½ ml. And kind of wash down the plate. I also like to tap it on the Benchtop to get all the media to come down to one edge of the plate. Now if you were to look at your plate underneath the microscope, you'd probably only see the occasional cell on the surface, and that's what you want to do. You're going to take this tube of cell suspension, vortex it, and then we're going to count it using a hemocytometer. Today we're going to be practicing loading a hemocytometer, and I've already cleaned my hemocytometer with ethanol and dried it with a Kim wipe, and I've also cleaned it with ethanol the cover slip, and I'm going to place the cover slip right down onto the hemocytometer and place it so it kind of is sitting in the middle. Then you're going to get your cell suspension and give it a quick mix to make sure all the solution is homogeneous, and then you're going to pipette up about 15 microliters. And when you have your 15 microliters, come close to your hemocytometer and expel about 10 microliters of your solution to form a hanging drop. Then you're going to touch the edge of this triangle here to load your hemocytometer. And it loads rather quickly. Okay? Go back and get some more cell suspension after you mix the tube, and then come in and load the other chamber. Once again, about a 10 microliter hanging drop, and touch, and it should load really smoothly. There you go. That's perfect. Now you can go ahead and count. Now I'm going to try to show you two common problems when filling a hemocytometer. One of them is the underload. So you form your hanging drop, but you don't have enough there, and you load your sample, it doesn't go in well, and try to pipette, and you form this kind of line as you're pipetting trying to fill that chamber. What happens is the cells actually go right up to the edge of the solution and form a line, and you won't get an accurate fill. The other problem is overfill. So I've formed my hanging drop, but I've got too much of a drop here. And when I touch the chamber, I overfill, and you can see it spreading over the silver counting area. Both of these are not good. You should clean your hemocytometer and start over again.